Hello everyone. Now we are going to discuss about projections of solids. So here a simple basic example I am taking to explain the projections of solid, that is projections of solids. So the basic example means here I am taking a cube which is having all square faces, all six square faces. So for that cube, how to draw the front view and top view, and what will be the front view and what will be the top view, we are going to discuss now. So first I want to show you the orientation in the first quadrant. Okay, so this one is the first quadrant, and in this I want to place the solid as the face. All the faces means the face which is bottom face is parallel to the horizontal plane, and one of the face is parallel to the vertical plane. That means your face bottom face is parallel to the horizontal plane, and the side face, one of the side faces is parallel to the vertical plane here. So here this one is the basic condition for the cube I am taking in the first quadrant. So in this condition, what could be the front view and what could be the top view, you can easily justify, because already we have discussed the so many classes about projections of straight lines and points. So with that knowledge, I think you can decide what is the front view and what is the top view. So here when you see the front view, when you see this object from front view means the view normal to the vertical plane. So in this condition we can see only the front face, that is a square face. Square means all the sides are equal. So that means here in front view we can see the square with the size of the cube. So here assume the size of the cube as 30 mm. So with 30 mm size we can see the square in the front view for the cube where it is placed in the first quadrant like this. Okay, so in top view again we can see top view means the view should be perpendicular, that is normal to the horizontal plane. So when you look at this cube in this condition from the top view, we can see again a square face, that is the top square face we can see, and it will be appearing like it is lying in a horizontal plane. So as we know already, so means here in top view we can see the square, that is also square. So that means here you can understand that in any view if you observe the cube in this condition we can see the square face, whether it's front view, whether it is top view, whether it is left side view or right side view. In any view it can give the square shape, that means all of these will be the square only. So here I want to show you the front view, that is the square, and I want to show you the top view, that is the square. So in any view we can see the square shape for this cube in this condition. Okay, as bottom face is parallel to the horizontal plane and one of the side faces is parallel to the vertical plane. Okay, so I'm showing the projection lines for understanding purpose. So for getting the final front view, top view, we need to rotate the horizontal plane straight to the vertical plane, then we can get the projections of cube in this condition. Okay, so before that I want to give names A B C D. E F G will be at back side, so we cannot see in this condition. So E F G H, A B C D E F G E G H is the required cube here. So now by rotating we'll get the projections like this: front view A B C D, top view will get A B F E. Okay, A B F E. In top view we can see A B F E. That means A means this corner is A, this corner is B, and the back corner will be F, and this corner will be E in the top view. So when you rotate, these AB points will come at the bottom. Okay, so like this we'll get the front view, top view, like this, both are square only. So now we discuss how to draw on a drawing sheet for this cube when it is placed in a first quadrant. So I want to show you the assume this is as a drawing sheet with XY reference line. So now first we need to draw the front view. So either views we can draw, and already we have discussed so many times, wherever we'll get the true shape of the object, first we start that view. But here if you select the cube, in any view we are getting the square shape only. Okay, so we can start from the front view or we can start from the top view also. So here again regularly I'm starting from front view only. So here I'm assuming this cube is 30 mm above the horizontal plane. 30 mm above the horizontal plane means it will be at a distance of 30 mm. The front view will be at a distance of 30 mm from the XY reference line. And again I'm assuming 20 mm in front of the vertical plane. 20 mm in front of the vertical plane means in top view we can see that. So it will be, the top view will be at a distance of 20 mm from the XY reference line. Okay. So it is 30 mm above the horizontal plane and 20 mm in front of the vertical plane. So now For drawing the front view, first we need to represent the square at a distance of 30 mm from the XY reference line. So first I want to show you the dimension 30 mm. So at a distance of 30 mm from the XY reference line, we can see the square shape in the front view. So after representing like this, take the drafter and locate the dimension normal to the XY reference line, that is 30 mm, and draw any reference line like this. I have shown you that is parallel to the XY reference line. Okay, so on this I have drawn the projection line also. So from this projection line, start the square with the size of 30 mm. So all the sides of the square should be 30 mm only, because square means all the sides are equal. So with using 30 mm side size, draw the square and finish the other projection line like this. Next we need to draw the top view. So for this top view again we need to draw the reference line, that is at a distance of 20 mm from the XY reference line. So why? Because means it is 20 mm in front of the vertical plane. So look at the 20 mm. So now again draw the projection line. So from that projection line again start the square. So before that I have completed the another projection line for top view. In between these two projection lines we will be getting the, we are going to get the square shape. So now start the square. So like this we'll get the top view. So these are the front view and top view. Like this we can draw the front view, top view. So after that give the names as whatever we got as per our imagination, and size is 30 mm, and the names are A dash, B dash, C dash, D dash, and A, B, F, E. So this is the way of drawing the projections of solid. So the projections of solid also you can easily understand, because you have gone through the projections of straight lines and projections of planes. So based upon that we can easily draw the projections of solids only. So this is the basic example I have explained now. So in later on classes we go for the solids like cone shapes and rectangular blocks, and next cylindrical blocks, and truncated cone shape, truncated yes, truncated cone shapes like that. Certain different solids will discuss how to draw the projections for those solids in different positions, in different orientations in the first quadrant. Okay, maximum I am choosing first quadrant only, otherwise in the examination he will give in third quadrant. So the third quadrant means the views will be getting in opposite direction. Okay, the top you will get above the xy reference line and the front will get below the xy reference line, because it is placed in the third quadrant. Okay, so other than this you won't give any problems. So I hope you understand this projection of solid. This is the simple basic example by using the cube, and later on classes we discuss some critical problems with easy steps. So once again I hope you understand my explanation, that is about projections of a solid. Okay, so if you still have any doubts, and feel free to give a comment, and thanks for watching my video. And if you are new member to me, please subscribe to my channel. And once again I would like to thank you all whoever subscribed to my channel and who are regularly watching my videos. And thank you so much for your comments, thank you so much for your feedback you are giving through the comments. So I'm feeling very happy for those comments you are giving. So once again thanks for watching my video, and thank you all.